So this is actually all you need to do to set up the socket. So this creates the network socket, and from here we can start calling the other functions on it. So this creates one of the endpoints needed to create a network communication. And since this is going to be our client, we're going to have to write another one of these on the other end that we can interact with and maybe send data to or receive data from. But basically, so this is one side of the network communication. So we need to now connect it to another side, basically, another socket. So in order to connect to another socket, we need to call the connect function that we talked about. But before we can get to call and connect, we need to actually be able to specify an address to connect to. So that's why we needed this net inet header. It contains a structure that we can define a few fields on so that we know the address and the port of the particular remote socket that we're going to connect to, the other one. So let's start creating that address structure and specify where we want to connect to. So we declare the structure for the address like this. So first we have to specify an address family. It'll be the same as the family of our socket. That's AF_INET. That's the first parameter that we passed in. So we have a couple fields that we need to define on this sock address in structure. And the first one is going to be the family, and it looks like this. It's just SIN_family. So this sets the family of the address, so it knows what type of address we are working with here. Then we actually need to specify the port that we're going to connect to. And it's the field, again, on that structure is SIN_port. So we could pass the port in as an integer, but the data format is slightly different from the structure that we need to kind of use a conversion function, but since we've included all the appropriate headers, it's already here. The conversion function, that's going to put the our integer port that we've passed in the right network byte order, is called H2ONS. That's HTONS, and it looks kind of like this. So as a parameter to this function, we pass the actual port number, then this function takes care of converting it to the appropriate data format so that our structure can understand the port number and we know exactly where we're supposed to be connecting to. So let's specify some port that we know isn't going to be in use by our operating system. There's a bunch that might be, so let's use something high. We'll use 9001 or 9002. So that's all you have to do to specify the port that you want to connect to remotely. Now that you have this, you finally need to specify the actual address, and in our case that's basically going to be like the IP address. In some cases you might be familiar with, if you want to bind to any address on your local computer, you can use the IP 0.0.0.0. But we're not going to need to explicitly specify any network address. There's a shortcut really already there for us, so we're going to use that. So the next field that we're going to define on this structure for our server address after the port is going to be, like I said, the actual address, and it looks like this. So there's a field SIN_address, that's SIN_ADDR, but that field itself is actually a structure that contains a field. So we can use another dot to get into the field within this structure. So just so it's not too complicated, server address is a structure holding some information about the address. In here, this SIN_ADDR is a structure itself, and that contains one field holding the address itself, the data of the address that we are trying to connect to. And that field is called s_addr. So that's the real server address that we're going to be connecting to. And we're going to just connect to our local machine. We'll write another TCP server to handle the connections from this TCP client. So since we're going to do that, we can use any address that's being used on our local machine. We can use that shortcut that we talked about, the IP of 0.0.0.0, but we have a step better than that. There's already a shortcut for that in the library, and it's called inaddr_any, which is the same thing as trying to connect to 0000. So this is basically all the information you need to actually define the address that you want to connect to remotely. So from here you can actually call the connect function. So the first parameter that it takes is our actual socket. So we can pass that in. And then we're going to need to cast our server address structure to a slightly different structure. Here it's a struct sockaddr_in. We're going to need to cast it to a struct just sockaddr. And that cast just looks like this. Oh, it needs to be a pointer to one, so we're going to need to pass the address too. So this casts our address to the right structure type, and we're passing a pointer to it, to this connect function. And then the last parameter to connect is the size of the address. So we can use the sizeOf function to get that and pass it in as our third parameter. So one thing to note is connect returns an integer that lets us know whether the connection is successful or not. So we can kind of use that to do some primitive error handling here. So we can assign it to an integer, and basically the way it works is if you get a value of 0, everything's okay. If you get a value of -1, then there is some error with the connection and it wasn't able to connect properly. So let's print out a message to the user if something goes wrong with that connection. So we can create a simple if statement that checks and make sure that everything is okay with the connection. We'll just print a message to the user, in this case using the printf function from the standard library.